नमस्ते बच्चों, हमेशा खुश रहो बच्चों। माई सेल्फ ओम प्रकाश, फैकल्टी ऑफ डिपार्टमेंट ऑफ मैथमेटिक्स अंडर फैकल्टी ऑफ एजुकेशन एंड मैथमेटोलॉजी, ज्योति विद्यापीठ वुमेन्स यूनिवर्सिटी जयपुर. Today I taught you group theory. In our previous class, I will see some theorems on group theory. The subject group theory is taught in BSc BEd PCM, 6th semester student. These are the lesson planning which are already discussed in your first class. These are the steps for planning a lesson which are already discussed in your first class. These are the components of a lesson plan which are already discussed in your first class. Now, group theory is a subject of mathematics under science stream and which are taught in BSc BEd PCM 6th semester student. In your last class, I will see the uniqueness of entanglement and uniqueness of inverse. Today, I see the theorems on inverse of an element in a group. This is fourth theorem of group. Now, the question is prove that the inverse of an element is the element itself in a group. That means A inverse of inverse equals to A for all A belongs to G. The statement of this theorem is the inverse of an element is the element itself in a group G. Let G star be a group. Take an element A belongs to G, then we have to prove that A inverse of A is equals to A itself. Now let us suppose that A inverse of inverse equals to A is true. A inverse of inverse is equal to A is true. Therefore, we can operate A inverse of inverse star A inverse. That means multiplying both sides by A inverse. We got A is equals to A star A inverse and A inverse star A inverse of inverse equals to A inverse star A should be true, and this implies that let's say A inverse equals to B, then inverse of inverse will become B inverse star B equals to A inverse star A inverse, and B star B inverse equals to A inverse star A should be true, where B equals to A inverse, and B belongs to G. This implies that B star B inverse is equal to E, and again A inverse star A equals to E by the property of entanglement. And A belongs to G implies that A inverse belongs to G, implies that B inverse belongs to G, implies that B inverse belongs to G. And which is true, because A equals to E, which is true. Therefore, if A inverse of inverse equals to A is true, then nothing has to prove. Thus, we can say that A inverse of inverse equals to A must be true. Hence, the inverse of an element is the element itself in a group G. The next theorem, theorem 5, it states that the inverse of the product of two elements of a group is equal to the product of the inverses taken in the reverse order in a group G. This is very important theorem, and this is used in many fields of sciences. Now, the question is prove that the inverse of the product of any two elements of a group is equal to the product of the inverse taken in reverse order in a group. Here, the product means any binary operation. Don't be confused about these things. That is A O B inverse equals to B inverse O A inverse for all A B belongs to G. Now, the inverse of the product of two elements of a group is equal to the product of the inverse taken in reverse order in a group. That means we have to prove that A O B inverse equals to B inverse O A inverse for all A B belongs to G. For this, let us consider a group G O be a group G O be a group. That means the algebraic structure GO be a group. Take any two element A and B belongs to G. This implies that A or B belongs to G by the closure axiom in a group G, by the closure axiom in a group G. Therefore, we got A O B inverse belongs to G by the close existence of inverse in a group G, because A and B are in G. Therefore, A O B are in G with the help of closure axiom. Therefore, A O A O B inverse also belong to G with the help of existence of inverse in a group G. Moreover, again we take A and B belongs to G, implies that A inverse and B inverse belongs to G, implies that B inverse O A inverse belongs to G. Now take A O B O B inverse O A inverse, which is equals to A O B O B inverse O B inverse by associativity in G. That means this will operate with this element by taking A O B as a single element. Now it will become again associativity A O B O B inverse O A inverse with the help of associativity. Again we can write A O E because B O B inverse equals to E, and E is the identity element in a group G. Therefore we can write A O E O A inverse. Again A O E equals to A by the property of identity element in G. Therefore we can write A O A inverse. Again opening the bracket, we got A O A inverse, and again A O A inverse is equal to E with the help of properties of identity element and inverse, and E is the inverse element in a group G. Therefore we can say that A O B O B inverse O A inverse equals to E. That means A O inverse of A O B is equals to B inverse O A inverse. Inverse of A O B equals to B inverse O A inverse. Therefore, we can take here A O B O B inverse O A inverse equals to E. Again, taking this in reverse order, that means B inverse O A inverse O A O B. Again, we use the associativity property and taking A inverse inside the A O B. We can take this A also inside this one. We got the same result. That means final output will be same. Here we can take B inverse O, A inverse O, A O B. When you again we using associativity, here it will become A inverse O A O B, and B inverse will be outside here. Then therefore we can write here B inverse O E O B, because A inverse O A equals to E. A inverse O A equals to E. Therefore here it will become B inverse O B, B inverse O B, and therefore is equal to B inverse O B equals to E. Therefore we can say that B inverse O A inverse O A inverse of B equals to E. Therefore we can say from 1 and 2, the inverse of A O B equals to B inverse O A inverse, but the inverse of A O B equals to A O B inverse. Thus A O B inverse is equals to B inverse O A inverse. Hence, the inverse of product of two elements of a group is equal to the product of inverse taken in the reverse order in a group G. In a group G. Hence the theorem. This session powered by the digital version 2.0, JAYOTI Vidyapeeth Women's University. and I hope all of you are satisfied with my digital session. If you have any queries, please mention in the comment box. I will try to resolve it. Thank you for watching my this actual video. Thank you.